All right, first on the agenda this morning, we're going to hear about maintaining open graded friction courses. First up will be Mark Woods. Mark's with Tennessee DOT. He's the pavement engineer out of the maintenance division. So with that, turn it over to Mark.
My name is Mark Woods. I work for the Tennessee DOT. I've met a bunch of you guys over the years. I worked in the materials division for a long time. As of about February last year, Tennessee created a position for the state pavement engineer. You know, we have pavement design, we have a bituminous engineer, who's Matt Chandler. We have pavement management engineer. We kind of wanted to create a central point for all things pavement, so that was that job. I applied and got it. So, the presentation I'm giving today, if you were in the state updates and saw the one from Georgia, it's generally reminiscent. It's basically a presentation about when we did a rejuvenating fog seal on some open graded friction course on the interstate. It's part of a commissioned UT study. Tennessee, like most states, we commission research projects. What we did is we've identified, Tennessee does OGFC by policy on almost all interstates. We've had that for a policy for about 7 or 8 years now. Getting close to where most of our interstates are going to be open graded friction course in the next year, but we don't have any maintenance strategy for OGFC. So we commissioned UT to investigate opportunities and options for maintaining OGFC. This was really the first phase of that project. You know, one of the main reasons that we commission the study is because if you're a materials person, by one approach, you do mixed designs on dense graded asphalts, and you do the volumetrics, and you might whatever tests you do for stability or whatever performance tests, and then you step over and do an open graded friction course design. It's pretty apparent that the failure mechanisms for open graded, gap graded porous mixes are much, much different than dense graded mixtures. So we know that they're much more dramatically different. They operate a lot different. They fail differently and probably need to be maintained. One of the most common things we see is raveling. We've actually noticed by interviewing our district maintenance guys over the last year or so through this project that even the way potholes manifest themselves, our district people we haven't really found a good way to describe it. Well, we think potholes manifest themselves in open graded friction course differently than they do for dense graded pavements. You know, our guys they're familiar with the areas, and they can almost tell you where they're going to have to go patch potholes in the early part of the spring or in the winter, whereas it's unpredictable for the open graded pavements, and so we're trying to get a model understanding of that. What we did in this project is we basically heard Georgia was fog sealing OGFCs. So we wanted to look into it. We were taking a really conservative approach because I'm kind of skittish with friction concerns. So this section was actually just intended to be a section to do a very short section of e-fog or the rejuvenating fog seal on OGFC so that we can monitor the friction, but the UT guys saw an opportunity and went and cut a bunch of cores while we were out there. So whereas Georgia did presentations, I think you guys did 90 lane miles, we did 300 feet. But this was a presentation of lab data. To get a little bit of extra data, we shot additional application rates on the shoulder. So you're going to have to memorize, you can either convert from metric to English, emulsion application rates, or you can memorize. Basically, the rates we did is we did 0.1 in the lane, and we did additional rates of a little bit lower, a little bit higher in the shoulder. For reference, when I asked the Georgia guys yesterday, they said their projects, they did 0.2 of a gallon per square yard, I believe is what they said. So twice as much as what's here. Let's see. Generally, there are no differences between our shoulder OGFCs and our lane OGFCs. We don't have a separate OGFC shoulder mixtures. They're paved and manufactured and placed the same way. On a lot of our projects, including this one, we paved the entire 10-foot shoulder with OGFC. So we cut 24 cores, we applied the material, let it cure for about an hour and a half, cut some cores. They were tested for permeability, texture, and there's a durability test I'm gonna go over. There's a laboratory test on the core. I believe it's the Florida test. It's a modified permeability. I'm not an expert with the methods. I believe it's one that Florida conjured up years ago. Basically, the way it is your permeability is measured by the amount of time it takes for the water to pass through. So a high number is not very permeable, and a low number is very, very permeable. So what you see here is data for the shoulder and the lane. You can see the zero values, mean the untreated cores. It is an interesting note that we've found throughout this small study was that the permeability was better in the traffic lane for untreated cores. We actually had better permeability in the traffic lane we did on shoulder, which you can scrounge up a couple of theories. It may be just from the traffic's keeping it clean. A lot of people, it's counterintuitive. You would think that the traffic lane that's receiving truck traffic would probably consolidate more and have lower air voids and worse permeability. For whatever reason, by our testing, for this one short section, the shoulder was less permeable. So pretty intuitive for the treated areas. The more rejuvenating fog seal you add, the worse the permeability. When they did the texture depth test, which is they do it in the laboratory, that's also intuitive. The more fog seal you add, the less texture depth you have. So this is the more interesting test that UT came up with, which is they took a Hamburg wheel track device and made a new wheel, which is basically a studded wheel. So you can see the studs are about 2 millimeters wide, 3 millimeters tall. Pretty rough looking machine there. And then they abraded all the cores with that. They actually did the texture depth before and after to see not just a mass loss from the abrasion, but the change in texture. Picture of basically what it looks like. You can see the calculation for mass loss is pretty basic. What did it weigh before minus the percentage loss. It was good. It was good data, meaning that the more fog seal you applied, the fog seal had a pretty clear effect on the more you added, the lower the abrasion loss, which is the reason we're doing it. We're hoping to slow down field abrasion of the pavements. We haven't really, this is really early on in the study, we haven't really gathered a lot of data. I mean, we got all this data with 24 cores. So we don't really have the ability to make a distinction of what's the permeability range that you want, or what's the abrasion loss limit that we want to keep it below, so that we could define what's the best application rate, so we can optimize the application rate. We hadn't made it that far, but we have verified some basic principles. More seems to reduce air voids while reducing abrasion loss. I don't really like this plot myself. You can get cross-eyed on this. It's basically for each individual rate, it shows the rate of change in texture depth before and after abrasion. So the two sections on the shoulder, you can see in every case, the texture depth increased after abrasion. We don't, it really ought to show for all of those what the texture depth was before treatment too, but that's me critical, being a little critical. So the things that we don't have slides on here, which is this was really a friction evaluation. I'm not going to tell you what the numbers were. It was a targeted friction evaluation, meaning we actually shot this on the lowest. We have our network level friction data, and we shot this on the lowest friction section of OGFC that I could find that was in a straight section of highway. And you go down the rabbit hole of, I didn't really like the numbers, so I haven't mobilized a larger project. I haven't mobilized the 90 lane mile project like Georgia did yet. even though this was the most critical section, we're going to do a second phase. Maybe we'll try 1,000 feet. We'll get a slightly larger. But we hope to do this in larger scale because it's a 2-year study with UT, and this is like, we're probably 2 quarters in. What we'll probably do is shoot some larger scale pavements, very risk managed approach to try not to put anything slick out there. And then we'll start observing pavement cracking data. We'll have those sections out there. We have, a good 700-800 miles of OGFC right now, centerline miles. So we hope to be able to further connect these tests with some longer range pavement data sections so that we can validate that the reduction in abrasion loss correlates to some other kind of field performance. Another part of the study is where there's actually a pothole patching component to the study. We did some pothole patching research projects for just all things pothole patching for maintenance on-call work. We had the UT guys follow our on-call patching crews and monitor the different methods. We're using cold mix or hot mix or what the ambient temperatures were, whether you spray tack before it's to optimize our in-house procedures. So now we're doing, anytime they patch potholes on OGFC, UT gets a phone call and they go monitor and take notes. Unfortunately, we didn't have that harsh of a winter, so they didn't get a whole lot of notes this past winter. I'd rather have a mild winter. That's really all I have. I'm gonna try to keep us on schedule. That put us right at 8:20. Does anybody have any questions?
I guess this question is for y'all and Georgia and anybody else that may want to answer it. Has anybody looked at some of the maybe cyclical triggers or the time when you would optimally start to treat these?
That was one of the objectives of this study. I mean, when we commissioned this study, we knew it was basically 2 things. We actually excluded winter maintenance. That's a whole other story. It was originally in there. We're like, that's too big of a study to do just basic maintenance and winter maintenance of OGFCs. So basically the 2 components we figured were pothole patching and this, fog sealing. Our goal is when we select a second round of fog sealing, doing a larger scale version of this, we were gonna try to do a selection of project segments of various age and distress. So we got some ones, some that are only 2 or 3 years old, some that are 7 or 8 years old, and see where you get the most returns. Probably the UT project will be over by the time we have any data from that's worth sharing. But that was the approach we planned on taking.
And over in Georgia, yeah, that was the primary goal. What we're trying to figure out was when is the right time and what effects it had on it. So we had 13 test sites, and that's exactly what we were doing, was to figure the timing out on it.
I was just going to say that we did a similar thing on the test track. I recall that we did that back in a previous research cycle, and it was in a section that was approaching structural failure. So we knew that we had cracking that was imminent, that was working its way from the bottom up through this pavement structure. It was in the group experiment test section from 2009. It had an OGFC surface. We fogged half of it and didn't fog the other half of it, and it had a significant effect on the development of cracking in that section. And I think the thinking that I've gotten from most state DOTs is that if you go out there at the 4 to 5 year mark before you start to see a kind of a change in the rattling and the integrity of the surface and the fog it, that can have a very significantly positive effect on rattling and cracking in the future.
Looking back, I think it may have actually been NCAT that inspired us to first start looking into it.
And I don't know if there's anybody from Mississippi, but I think that's something that they're doing. Chief, for about 4 or 5 years.
The guy that started the question.
Oh, yeah, okay. All right. But that's what I would recommend based on what we've seen in Alabama when we've had premature failures, what we would consider to be premature failures of OGFCs. If you can hit it at 5 years or right before 5 years, you might be able to head that off at the pass and bump out into a significant life extension.
Thank you very much.
Thank you, Mark.